All right, guys. Let's go ahead and get, let's see. We are going to talk about the homework that you guys had to do. And then, you know what? Your new work, I'm not even going to really discuss too much. We'll talk about it a little bit because that's really just a review. So we are going to be wrapping up acids and bases here fairly soon. And I want to make sure that we are really, really good on calculating pH. I know there were some issues with that earlier. And let's see. So I think our homework for today, yep, this is it. You guys previously had done these problems. We worked through them in class, right? We did 1 through 4 in class yesterday. And we now are going to look at 5 to 9. All right, that was your homework. Hopefully you guys all got that turned in. I haven't checked it yet. So, all right. And by the way, so we have new times for everything. So homework, I'm making due at 8:30 in the morning. So that's kind of when the school day starts. So make sure you have the homework in by 8:30 in the morning, please. It's best just to do it the night before. That makes everything a lot easier. So if you just could just do it, you could do it right away whenever you have some time the day before. Don't wait till the day that it's due. Unless you have to. If you have to, you have to. It is what it is. But generally, try to just do it. Do your homework for tomorrow. Do that today and just turn it in right away. All right. So let's go ahead and get started here. Number 5. So we're looking at some different solutions and similar to some stuff that we've looked at before. Let's do this. So we dissolve 0.0749 moles of sodium cyanide. So this right here, that's nice. Let's just identify what everything is. This is going to be your N because we have moles there, right? We're dissolving in water to make a solution with a final volume. It tells us, well, that's volume of 235, this got skipped to the other line here, milliliters. So that's our volume. But remember that we always want volume in what units? What do we want volume in? Not milliliters, but liters. So this volume should be converted to liters. And the way we do that is we take this decimal point and go 1, 2, 3 spots to the left. So that's 0.235 liters. So we have an N, we have a V. What is the molarity? So we're solving for M. And we know the equation M equals N over V. So we can do this one, right? And at this point in time, just plug it in. The biggest thing, so there's a couple really, really important factors that you need to be aware of. You need to identify what's what in the problem. You need to figure out what you're solving for. And you need to always keep in mind that the units here have to be liters for volume. So with that said, let's plug the numbers in. It's going to be 0.0749 moles divided by 0.235 liters. So let's clear that. 0.0749 divided by 0.235 gives us 0.319. Round that 8 up to a 9 because of the 7 behind it. We do have 3 significant figures, so 0.319. The units here should simply be moles per liter. Moles per liter. All right, I'm going to pause there. Does anybody have any questions? If you guys have any questions about anything, feel free to stop me as we go. All right, and if there are no questions, I'm just going to continue on. I've been having some technical issues today. I don't know what the deal is. Hopefully we don't have any issues for this class. But if we do, we do. So sorry about that. All right, number 6. If you dissolve 8.11 grams, unfortunately, this is not moles, but this is a mass. So we're thinking we probably need to convert that to moles in water to make a solution with a final volume of 75 milliliters. Okay? We need to convert the volume to liters. And what you might be tempted to do is to say, oh, okay, that's just 0.75 liters. But that's wrong. Okay? When you have something like only 2 digits here, oftentimes people make that mistake. So be careful. You need to move that decimal point 1, 2, 3 spots to the left so the volume really is 0.075 liters. You're welcome to use your calculator. Just take that number, divide by 1,000. That's fine too. Okay? So we have a mass, and we want to know the molarity. Well, how do we do that? How do we do it with a mass? We don't have N, we don't have moles, so what do? We need to convert the mass to moles. And the way we do that is with the molar mass of potassium sulfate. And that means you're going to need to remember what in the world is potassium sulfate. That whole naming stuff you guys need to remember. You know, you can always look it up if you have to, but keep in mind, looking things up on the internet will lead you, some of the time, most of the time is right, but some of the time is wrong. So hopefully the person who's writing down the formula gets it right. Wikipedia tends to be right, but ordinary just individuals can be wrong all the time. Potassium sulfate, what is that? That is, so sulfate is SO4 2 minus, and potassium is K plus. We know it has a 1 plus charge. Yeah, you're right. You know how it was a 1 plus charge because, once again, it is right in the first, it's in the first column here. So we go +1, +2, skip all the stuff in the middle, +3 for aluminum, skip carbon, 3 minus, 2 minus, 1 minus. So potassium's in that +1 column, which means if you have +1 and -2, our formula is K2SO4. Once we have our formula, we can get the molar mass, and we can use the molar mass to convert the mass to moles. So what I'm going to do is I'm just going to write down my 8.11 grams of potassium sulfate. And I'm going to write my molar mass down here, right? I'm converting to moles, so 1 mole should be on the bottom, and the mass should be on the 1 mole should be on the top, and the mass should be on the bottom. So let's do that right now. Calculate potassium. Let's do it this way. You guys can see here. Potassium on the periodic table is right over here. So that's going to be, we have 2 potassiums, so it's going to be 2 times 39.0983. And then we have 1 sulfur. Sulfur's right over here. So plus 32.066 for sulfur. Plus, we have 4 oxygens. 4 times 15.999. And that's going to get us our molar mass of potassium sulfate. 174.26. 174.26 grams per mole. So back over here to the problem, we got our molar mass. And so what we're going to do is, because it's on the bottom, we're going to divide. Remember, multiply by numbers at the top, divide by numbers on the bottom. So this calculation is 8.11 divided by, I'm just going to use the number in my calculator rather than rounding anything off in my calculator. Just do 8.11 divided by my previous answer, and that's going to get me my number of moles, 0.0465. 0.0465 moles. Okay, we are almost there. We've got N, we've got V, so M equals N over V, so that's going to be 0.0465 moles divided by 0.075 liters. And I'm going to use the number in my calculator so I don't have any rounding errors. Divide by 0.075, and that's my final answer. 0.62, and that 0.05 is going to round up to a 1, so it's going to be 0.621. 0.621. You could use just a capital M, or I like to just say moles per liter. Okay? Now, any questions so far as we're doing this? This number 6 is going to be super important as we go on to our pH calculations. Being able to solve a problem like that, very, very important. Okay, you will have to do that on the test coming up next week. Test shooting for next Tuesday. Okay. Number 7. We have 27 milliliters of 0.5 molar sodium hydroxide. How many moles of sodium hydroxide are in it? Well, this time, how many moles? That means we're solving for N. This, you see this capital M here? That's our molarity. And this is our volume. And once again, always, 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 we need to convert the volume to liters. And so I'm going to move that decimal point 1, 2, 3 spots. So it's 0.027 liters. Okay? So our equation M equals N over V, but we want to solve for N. So I'm going to multiply both sides by the volume. So that gets me N equals Vm. Okay? And we've done problems like this before. This problem also looks similar to and you can just straight up multiply the two numbers, but the problem also kind of looks like a conversion problem, which is a useful way to think about it. So the volume is the amount that we have, and the molarity is the conversion factor. So let's look at how that works. So we're going to put 0.027 liters as the amount, and our molarity, 0.5 moles per liter. That's our conversion factor. So a simple multiplication in your calculator of 0.027 times 0.5 is 0.0135. 0.0135. As for the units, we look here, our liters over liters cancel out, right? Liters over liters cancel out. We're left with moles, which is exactly what we're solving for, right? We're solving for moles. So it should be no surprise that our units are moles of sodium hydroxide. Okay? So, if there are no questions, I'll go on to number 8. Stop me if you have a question. Okay? Number 8. So let's suppose we wanted to make something. We want to make 500 milliliters. And once again, that's going to be our volume. And once again, we want the volume in liters. So move the decimal point 1, 2, 3 spots to the left. And that's going to be 0.5 liters. And we have 4 sig figs on that one, so a lot of significant figures. But I'm just going to write it like this, 0.5 liters, or a half a liter. So we wanted to make a half a liter of 1 mole per liter iron 2 nitrate. So what is the mass of iron 2 nitrate do we need? This here, that's our molarity, and we're solving for the mass. But we can't solve for the mass directly. Instead, we need to first solve for what? We need to solve for N, because mass and moles are related. They're related through the molar mass of the material, but we can also, you can always convert between moles and mass. So we need to solve for N first because it's in the equation M equals N over V, and we already have the equation N equals Vm. So let's go ahead and solve for N first. We can do that fairly quickly. N equals Vm, which is 0.5 liters times, well, this is a nice conversion factor, 1 mole per liter, right? 1 mole per 1 liter, which is, don't need calculators for this one, 0.5 moles. Okay, that was easy. Now the harder part, we need to convert those moles to grams. So 0.5 moles of what? Iron 2 nitrate. Once again, this naming is important. Iron 2 means that we have an iron with a 2+ charge, and the nitrate we look up and we remember nitrate is NO3 minus, so because this has a 2+ charge, our formula is FeNO3 2, which means we have 2 nitrogens and how many oxygens? How many oxygens do we have there? A lot. 6. 3 times 2 is 6 oxygens. So I'm going to go ahead and calculate the molar mass of that. Let's see if we can, you know what I'm going to do? I'm going to fold this. There we go. You can fit more in that way. Nice. Look at that. Isn't that nice? That's nice. All right. So now we're going to calculate the molar mass of iron 2 nitrate. Oh, and by the way, this is a bad problem because iron 2 nitrate, I don't think it generally exists. It would decompose, so it's not a very stable compound. But anyway, doesn't matter. So if you maybe looked up iron 2 nitrate, you're like, what? It's not up here. Or maybe if you found something, you know, I don't know what you found. But anyway, so iron 2 nitrate. We have one iron that's going to be 55.845. And we have 2 nitrogens, so that's going to be 2 times 14.007. And we said we have 6 oxygens, right? 3 times 2 is 6, plus 6. And each oxygen is 15.999. That gets us 179.853. Okay? That is our molar mass of iron 2 nitrate. So, now, is that going to go on the top or the bottom? What do you guys think? We're starting with moles. We want to go 2 grams. Is this 179 going to go on the top or the bottom? Well, if we're starting with moles, our 1 mole is going to go on the bottom, and that 179.853 grams goes on the top this time. So it's going to be 0.5 times that. So 0.5 times our molar mass, which is, that's a lot, right? 89.9 grams. 89.9 grams of iron 2 nitrate. Okay. Questions? Are we good? All right. The last question is the most important question of all, and that's going to be a question of pH. Homework assignment on this. So practice on these pH calculations. I know it's been, you had spring break to forget all this stuff, so I'm going to give you guys plenty of practice. So number 9, we have 5 grams of this, and is this an acid or a base? HClO4. Well, what we do is, if we don't know, okay, is this an acid or a base? And we know it's got to be one or the other because it's a pH calculation. Well, we look in front, and that in front is an H. And so anytime you have an H in front, it should be an acid, which it is. This is called perchloric acid, which is a fairly strong acid. Okay? And we know, if you didn't know what this was, which I didn't expect you to know what it was, you should know it's an acid simply by looking at that H in front. H in front, that's an Arrhenius acid. And anytime you have an H in front, it's going to be an Arrhenius acid. An Arrhenius base should be anything that you have an OH in it, so a hydroxide, so some kind of metal hydroxide. That would be an Arrhenius base. Now, on to the actual problem. We got 5 grams of that in this volume, and we want to know what's the pH. Well, how do we do that? Remember that pH for an acid is equal to the negative log of the H plus, and remember that the brackets means molarity. So this means your H plus molarity, or in other words, your acid, let's write it this way, your strong acid molarity. Okay? So we need to calculate molarity before we can calculate pH. And how do we calculate molarity? We do it by converting this 5 grams into moles and then dividing by the volume. So we do have a volume, and let's just go ahead and do that right away. Your volume, convert that to liters. That's going to be 0.125 liters. Okay? Now, 5 grams, we need to convert this 5 grams to moles, just like we've been doing. So I'm going to write down my 5 grams of my HClO4. And I want to convert to moles, so 1 mole on the top, and my molar mass is going to be on the bottom. And that's going to get me, let's do this once again. I need to calculate the molar mass of my perchloric acid. We have 1 hydrogen, so 1.0079. We have, let's see, 1 chlorine. Chlorine is 35.453. And we have 4 oxygens. 4 times 15.999. So our molar mass is just about 100, 100.457. 100.457 grams per mole. Okay? So the calculation is, if it was exactly 100, that would be nice, but it's not. Anyway, so it's going to be 5 divided by that molar mass, which is about 0.05, but exactly 0.04977 moles. Okay? Next, we need to calculate the molarity because we need the molarity of the acid to calculate the pH. So the molarity is going to be N over V, which is this 0.04977 moles, divided by my volume of 0.125 liters. Let's do that. Divided by 0.125. And that gets me almost 0.4, but not quite. 0.398 units here are moles per liter. And by the way, as I talk about units, the units of pH, there are no units of pH. pH is really just a scale. And that happens anytime you deal with logs. You could just basically throw the units out the window, okay? So the molarity does have units, but once you plug it into this equation, the units just go away. All right? So our pH, finally, is going to be the negative log of this, that H plus molarity, which is equal to the strong acid molarity, which is 0.398. And so once again, I just use the number of my calculator rather than rounding, and negative log of that, plus it saves me, time typing in stuff. And that's going to be, ooh, look at that. That's pretty cool, actually. It doesn't happen too often where the pH is essentially equal to the molarity. Wow. I did not do that on purpose. That's really cool. I think that's really cool. Maybe you guys think it's really cool, but I think it's super cool. The pH is actually more or less equal to the molarity. So it's 0.4. Now, we need to write down 0.400. Why? Because we actually have 3 significant figures and we need to write down all the significant figures. But that's your pH. Okay? And I think we found like one of the very, very, very few times where the pH is actually equal to the molarity. Okay. So that's it for today in terms of going over the homework. I think I just want to mention one brief thing before I end, because the new homework that I've given to you guys is really, it doesn't have any new concepts in it. So it's just more practice of this pH stuff. And it might seem like a lot, but the main reason I'm doing this is because I've had so many people that didn't turn in their previous homework, the one right before break. And so I want to really, really make sure you guys know how to calculate pH and know how to calculate pH for acids or bases. So last thing I want to do is, the only thing that I haven't mentioned today is, well, what about bases? Now, you guys listening probably, who's Amy or AMI? I don't know. If you're in my class, I did give you homework. If you're not, I don't know how to give you homework, but you can follow along. Let's see. So we've said for pH for acids, the definition of pH is negative log of your H plus molarity. And we've said, well, what in the world is this whole P thing? That P is a negative log. P is the power. So pH stands for hydrogen power, or power of hydrogen. Okay? But we can relate that and do a separate calculation for bases. So this is for acids. And you can calculate bases by this equation, 14 plus the log of the OH minus molarity. Okay? This is a derived equation, and you guys don't really need to know how to derive that equation. Okay? But it's a derived equation. Basically, if you want to know more about it, I can get into it, or you can just watch some of my honors chemistry videos, which are on YouTube, and I derive it there. But I'm not going to get into it now. So the pH for a base, and it's important that you guys distinguish these. This is going to be for a strong acid, and this is going to be for a strong base. Okay, and it's right there in the formula. You know that this is a base because it's got the OH minus in it. You know this is an acid because it's got the H plus in it. Okay, so you should not get them confused. But when you do your homework, you might be wondering, and you should ask yourself, is this chemical an acid or a base? And a little bit of review. Let's look at the homework. Where is the new homework? Gotta find it. Aha, here it is. So this is the new homework. Okay, so we can talk about it a little bit. When you see these things, when you see two different chemicals and you calculate the pH, before you calculate the pH, you need to know which equation to use. And the only way you know which equation to use is by looking at this and figuring out, is it an acid or a base? Well, we know if there's an H in front, that's an acid. So for this one, you're going to use the acid pH equation. And this is potassium hydroxide. You see that OH, you say, okay, that must be a base. And so you're going to use the base equation. All right, and we can go through all of these and look at, okay, NaOH. Guys, NaOH, is that an acid or a base? What do you guys think? NaOH, is that an acid or a base? NaOH is a base because we have OH. So for that equation, for this problem, you're going to use the base pH equation, which is pH is 14 plus the log of the base molarity. Okay? And this one, all right, HBr, is that an acid or a base? You have an H in front, so that is an acid. You use the acid equation. Down here, lithium hydroxide. Last one here, is that an acid or a base? It is a base. Yes, you're right. So you guys, for homework, is only one sheet of paper. For homework, guys, do this, and we'll talk about it next time. I'm not going to solve any of these for you guys, and we'll just talk about it next time. So, any questions before we sign out here? We got about 10 minutes if you guys have questions, but if you don't have questions, we'll just end early. You guys can work on your homework. What do you guys think? All right. Well, with no questions, I'm just going to sign out early and let you guys work on these questions and for homework. And you guys can finish up early, all that kind of stuff. And I'll see you guys here, same time, same place, tomorrow. And we'll talk about this, and then we'll talk about one new concept for acids and bases. All right. See you guys. Have a great rest of your day.